Alrighty, we're back at it for a new chapter. This chapter is all about parallel and perpendicular lines. The nice part about this is you guys, for the most part, should already know what those are. And what we're going to do is add on some properties about parallel and perpendicular lines. So, if we look at a couple of examples, we want to make sure we can describe relationships between two lines, two planes, and then making sure we can also look at those angles. So, first set of lines we look at are parallel lines. And those are lines that excuse me, are in the same plane that do not intersect. So what that would look like is something like this, and the symbol would be maybe MN is parallel to PR. Okay. Second one is perpendicular lines. Again, you've already heard of this, and that would be something like this, where we have a right angle pretty much everywhere in most cases, and that would be represented by MN perpendicular to PR. Sorry if you had a little bit of a glitch pause there. Okay, last thing are skew lines. You may not have heard of these before. Okay, so skew lines would be something like AD and RS. Those lines are skew. They're not going to intersect ever, but they're also not parallel because they're not running in the same direction together. So those would be skew lines. We do not have a symbol for those. We will talk about those only briefly. Parallel and perpendicular is what you really want to be concerned with. So if we look at a couple of these examples, I'll do the first one. I'm going to have you guys do the rest for tomorrow. BA and GH. So if we looked at BA and GH, okay, so they're running in the same direction, okay, they're never going to intersect, so we would call these parallel. I'd like you guys to try the other four for class tomorrow. Make sure you have these done when you come in. Okay. Next thing, adding on to that, is a transversal, or just a line that cuts, we could say, other lines. Creates several special angle pairs. So basically, this is your transversal. Okay, it's cutting those other two lines by going through them. Interior angles, the first ones. Okay, you always go based off of, for interior and exterior, you always go based off of those two lines that are running from left to right. So your two horizontal lines. Interior angles are anything inside it. So your interior angles in this case are going to be 3, 4, 5, and 6 because they are all inside those two parallel lines. Oops. Sorry about that. Let's erase that. Alternate interior angles. Okay, so you're still inside. Okay, so it's got to be between 3, 4, 5, and 6. Alternate deals with the transversal, and anytime you alternate is when you switch over the transversal. So alternate interior angles would be like angle 3 and 6 and 4 and 5 because they alternate over that transversal. Okay, they're also still inside the two lines. Same side interior angles. Okay, so now you're talking about same side, so you're not going to alternate over the transversal. You're just talking about the same side. Again, you're still inside. You're still inside those two lines. So same side would be like 3 and 5 and 4 and 6. Okay, they're on the same side of the transversal and they're both inside the two lines. Okay, that's kind of your dividing point. Everything else is going to be exterior. So exterior angles are going to be outside those two lines. So you have 1, 2, 7, and 8. Those are all outside. Alternate exterior would mean that they have to alternate over the transversal and their exterior. So you could have like 1 and 8 and 2 and 7. They alternate over it and they're outside the two lines. Same side exterior means, okay, we're on the same side of the transversal and we have exterior angles. So it would be 1 and 7 and 2 and 8. Corresponding angles, okay, this is the one that's kind of by itself. Okay, corresponding angles is like if you're looking at this set of angles and this set of angles, you can see how there's kind of four squares in each one. Corresponding angles would be like angle 2 and 6, or 1 and 5, or 3 and 7, or 4 and 8. So basically, if it's top left in the top square, then it's top left in the bottom one, like 1 and 5. Okay, so they're corresponding, they're in the same spot, just in the separate angles. So again, if you want to make a note of it, interior, exterior, that deals with the two lines. Your alternate versus the same side, that deals with your transversal. Okay, so you have a combination of both of those. So if it's interior exterior, that decides if it's inside or outside the two lines. If it's alternate or same side, that determines if it alternates over the transversal or stays on the same side. If we look at one of these examples, okay, we have kind of three different lines. Okay, we can view at any given time, we could say that this and this are our two lines and that this is our transversal. We could also say that instead these are two lines and this is the transversal. Okay, so we can do it any way we want depending on what angles we're looking at. So let's go back and look at all these examples as we go through. Okay, so angle 7 and angle 11. Okay, if we look at this, these are our two angles that we're looking at, okay, or our two lines rather that we're looking at, and this is our transversal because it's cutting through. So if we look at 7 and 11, this is one. If we have that box around it, that angle 11 and angle 7 are both bottom right, so we would say that those are corresponding. If we look at angle 2 and 9, so I'm going to go back and erase everything. So we look at angle 2 and angle, where's 9 at? Right here. Okay, so again, we're dealing with this is my line, this is my line, and this is my transversal. Okay, so these would be they're on the same side of the transversal, and they stay inside those two blue lines. So we would say that they are same side, interior. Okay. I'd like you guys to try C, D, E, and F. So try these four for tomorrow. Okay, one more thing to look at. I'm going to do one of these and then let you do the rest. Key with these, when we have a shape like this, is to extend everything. Okay, we want to identify all our special pairs, and you won't have to extend everything once you get used to it. But for now, go ahead and draw your lines like they're going off in every direction, and you're going to get what looks like now two lines cut by a transversal. So if we look at angle 1 and angle 3, here's our two lines. Here's our transversal. So angle 1 and 3, they alternate over the transversal, but they're inside those two blue lines. So we would say that they are alternate interior angles. I'd like you guys to try B, C, and D, and bring those for tomorrow. Last thing I want to look at, a couple of examples that I'm going to have you finish. Okay, solve for x and y. That automatically means you need to be making a system. Okay, so look at what you can create. There are lots of different ways to do this. Okay, but think about what you know about these angles together. Think about what you know about these angles together. See if you can come up with two equations that you can solve in a system. So you need two things that make sense. Don't just add them up, set them equal to 180 or 90 or set them equal to each other. Make sure they make sense with what you're looking at. Think about unit 1. Again, the last one I'd like you to try again is finding angle 1. We've seen lots of examples like these. Okay, again, think about what you know about these angles. Once you find one of those angles, you can go ahead and find angle 1. So I'd like you guys to try 4 and 5. This was a shorter video, so try 4 and 5 and make sure you have everything else that I highlighted done for tomorrow. Stay classy, Warren.